Welcome back to the third day of essay question practice series, third day. So today is a classic today we are going to discuss a classic example. So wait, essay question practice 2. Okay, today we are going to discuss a classic question that they can always ask. Okay, a type of question that they can always ask in your exam for inorganics. So here, let's start by reading the question. Write the chemical formulas of the substances B to G in the flowchart given below. Okay. So we just have to find out the substances they have given. Okay. So the compounds. Then Lamai, now you can see some easy points are there, Lamai. Some easy points are there for you to identify the result. Now see, for example, identify what compound it is. Turns the filter paper moisten with Nestler's reagent brown. Now you know that Nestler's reagent brown is turned by ammonia. You know that very well, okay? From inorganic, that is a basic knowledge. Ammonia only turns Nestler's reagent brown, okay? Only ammonia. That is a characteristic. Here, I'll write it. Only ammonia turns Nestle filter paper turns filter paper moistened with Nestler's reagent brown. Okay, now we are supposed to find. Now we are writing the answer of the first one. Okay, then D is ammonia. Then what about C? A green precipitate. Now by triangle they have indicated a precipitate. Okay. Then a green precipitate. Green precipitates can be chromium hydroxide for Cr3+, when NaOH is added, chromium hydroxide, a green precipitate, and nickel hydroxide when you add not excess. Sorry, no, not even this one. Okay, even though you add excess or even though you add limited, the for nickel also you get nickel hydroxide. Okay, chromium hydroxide and nickel hydroxide both are green precipitates. Now I add dilute HCl. When I add dilute HCl, they become they are aqua complex. Okay, they become the aqua complex, and then for that dimethyl uh, dimethyl glyoxide, we call this DMG. Okay, DMG, careful listen. DMG DMG is a characteristic. Now it's not there in the syllabus now, but in all syllabus, so it's worth knowing. Okay, it's worth knowing. DMG is reacting with DMG. Reaction with DMG is characteristic only for nickel 2 plus. Okay, only for nickel 2 plus. Therefore we can confirm that C is nickel OH2, nickel hydroxide. Okay, because DMG is characteristic for nickel. DMG is characteristic for nickel. For Ni2 plus, when DMG is added, a red precipitate is obtained. Okay, a red, like because it's partially soluble, a red precipitate, you can see a red precipitate, red PPT. Okay, when we add DMG for Ni2 plus. Okay, then G will be Ni2 plus, or you can also write Ni Ni H2O6 2 plus. This is also accepted. Okay, this is also accepted. Then B. Okay, from flame test. From flame test, brick red brick red color is given. We know that crimson red is given by lithium 2 plus, and brick red is given by calcium. Okay, calcium. Brick red is given by calcium. Therefore, this has to be Ca2 plus. Okay, Ca2 plus. But HCl is added. Therefore, this can be Ca2 plus, or you can write CaCl2. Okay, for both marks will be given. Okay, for both marks will be given. Don't worry. Then E. To find out E, unclear. Ramai, I want to emphasize this point here. Unclear, okay? Unclear. Unclear means always sulfur. Sulfur solid is present. Unclear means a turbidity, okay? In other words, indication of turbidity. Unclear means turbidity, okay? Turbidity. Remember that one, Ramai, I'll highlight it. Unclear means turbidity. So if unclear term is given, then you have to know that it is sulfur that is present. So this is an oxidizing agent. No, this is an oxidizing agent. Okay. So if sulfur is present here, the reduced form S2 minus has oxidized to S sulfur. Okay, S2 minus has oxidized to sulfur because it is the reduced form that will oxidize. No, you can't write SO2, sorry, SO4 2 minus, SO3 2 minus like that. No, so S2 minus goes to sulfur. So S2 minus is oxidized to S, and here Cr2O72 minus is reduced to Cr3 plus. Cr3 plus. So Cr3 plus, you know that Cr3 plus is green. Cr3 plus is green. Therefore, unclear green precipitate is given. Sorry, like a turbidity. Okay, unclear green solution. Then we can write E as now HCl plus Ca2 plus and sulfur. No, S2 minus. No, so Ca sulfur. This is B. Okay, this is B. This is CaS because here S2 minus is there, here calcium 2 plus is there. Okay, then S2 minus calcium CaS forms CaCl2 plus H2S. Okay, so E is H2S, F is CaCl2. So I'll circle the answers. E is H2S, F is CaCl2, F is CaCl2. G, better to write this one. Okay, better to write this one. Then D is ammonia. Then C is nickel hydroxide. Which is a green precipitate. Okay. Then B is calcium sulfide. Okay. Everything is done now. Let's write the answers. B, CAS, C, nickel hydroxide. D is ammonia, no? Ammonia. Then E is H2S. F, CaCl2. G is nickel 2 plus, or Okay, now B to G, B to G. Then the next part. Let's go to the next question. Let's go to the next question. Second one. In second question, let's read the question. This is also like a how can we say this? Like a common calculation question. Sodium thiosulfate is a commonly asked calculation question. Okay. Sodium thiosulfate is simply standardized. Oh, we have not completed that, right? Okay, second one. Sorry. This is the A second one. No? A second one. Identify the three cations and anions present in the mixture of compounds A. Okay. For NH4 plus, if a base is added, an ammonia gas is released. Okay, this is the theory. Therefore, NH4 plus is present. This is the ugly color. NH4 plus is present. Okay. Then calcium sulfide is there. Okay, calcium sulfide is there. So calcium 2 plus. Okay, this is the theory. No? Then cations will be Ca2 plus, Ni2 plus, and NH4 plus. For anions, we have only S2 minus. Okay, S2 minus. Then third part of the question. Write the balanced chemical equation for the reaction between gas E and acidic K2Cr2O7. Okay. We can write Cr2O7 2 minus plus 3S2 minus plus. You can balance this by writing and just giving the answer for now. 7H2S plus 3S plus H2O plus 2Cr3 plus. Okay? 2Cr3 plus. Oh, you can write K2Cr2O7 plus H2S 3H2S plus 8H plus 7H2O plus 3 sulfur plus 2Cr3 plus 2 potassium ions. Okay, both of them, the answer is correct. Then let's go to B part. Question number B1. Question number B1 is a common type of calculation question, which is a sodium thiosulfate. Let's read. Sodium thiosulfate is simply standardized by titrating it with the iodine formed when excess potassium iodide is added to a known volume of a standard acidic potassium iodide solution. Okay, a little bit confusing the question, but let's read the next part of the question. First one, 25 cubic centimeter of 0.02 mole D-3 of standard KiO3 solution. Okay, 20 cubic centimeter of 1 mole D-H2SO4 solution. Okay, and 10 cubic centimeter of 0.5 mole D-3 KiO solution were mixed in a titration flask. Write the color change that take place here. Okay, before writing the color change, let's go in this way. Okay, first I will write the answer for the second one and then to the first one. The answer for the second one will be 6H plus, because when you do this sodium thiosulfate questions, iodine iodide questions, then you will remember. You don't have to write and balance, you will remember automatically, because that's how frequent they ask this type of questions. 3I2 plus 3H2. Okay, now then IO3 minus anion is colorless. I minus is colorless. Okay, colorless. I2 in water it's yellow brown. Okay, yellow brown in color. If you write brown also, no issue. Okay, better to write yellow brown. Okay? Better to write yellow brown. Then okay, the color change. So the color change will be from colorless colorless to yellow brown. Colorless to yellow brown. Then the third part of this question. Third part of this question. Find the number of moles of I2 formed. Okay. Now find the number of moles of I2 formed. Let's find first moles of IO3 minus equals to 0.02 mole 25 in 10 power minus 3 d in 3 is equals to I into 10 power minus 4 moles. Okay. Then let's find the moles of I minus. Okay. For moles of I minus is 0.5 mole d minus into 10 in 10 power minus 3. 5 into 10 power minus 3 moles. Okay, 5 into 10 power minus 3 moles. IO3 minus, next let's compare the stoichiometry. 1 is to 5. Therefore, for 5 into, then we have to find out who is the limiting reagent. Okay, find who is the limiting reagent. Find who is the limiting reagent. Okay, limiting reagent. Find the limiting reagent. Then lamai moles of IO3 minus is 5 into 10 power minus 4. For 5 into 10 power minus 4 moles of IO3 minus, we need around, okay, let's calculate and see. For 5 into 10 power minus 3, 4 moles of IO3 minus, we need from this one. Therefore, for 5 into 10 power minus 4 moles of IO3 minus, we need how much? 5 into 10 power minus 4 into 5 equals to how much? 2.5 into 10 power minus 3. We need 2.5 into 10 power minus 3 moles of I minus. Okay, we need that much. But we have 5 into 10 power minus 3 moles of I minus. Therefore, IO3 minus is the limiting reagent. Okay. IO3 minus. First, we have to find the limiting reagent. I'll explain this question again at the end. First, let's figure out how to go to the answer. Okay, limiting reagent is IO3 minus. Then, now we can use the stoichiometry again. IO3 minus to I2 is 1 is to 3. Therefore, moles of I2 formed is equals to 3 into 5 into 10 power minus 4 moles. 1.5 into 10 power minus 3 moles of I2 is formed. Okay, so this is the answer. This is the answer. Okay, now first, now they have given a question like this. They have given here is excess also. Excess of acid and excess of K with acid. The limiting reagent is already given in the question itself. But in case, okay, we should just find out. We will just find out for the question. First, we will find out the moles of IO3 minus, then moles of I minus. Then we know the stoichiometry. From the stoichiometry, we can decide who is the limiting reagent. In the if you don't have time, if you feel like you don't have time to compare, then read the question twice. In the question they have given, the limiting reagent is other two excess, therefore limiting reagent is IO3 minus. Therefore, we know the moles of IO3 minus. IO3 minus to I2 is 1:3. Therefore, we can find the moles of I2 formed. Students, for the rest of the question, I will send the answer. The discussion will end on this one. Okay, thank you.